So today we are going to see the concepts of functions, the theoretical concepts of functions. So far we have discussed about the generations of programming language, how C evolved, what are the characteristics of C. We discussed about the basic data types that are available in C, the different operators that are used in C, and as well as we also discussed about the looping statements. And along with that, we also completed the theoretical concepts as well as the operations that are available in arrays and string. So all these arrays operations as well as the string operations we discussed so far, that is without using the inbuilt functions. So today, let me get into the theoretical concepts of functions. So what do you mean by a function? So generally speaking, functions actually divide a large program into segments. So it is something similar to the concept of divide and conquer, where you break up a program into a number of segments. And what these segments do, they do a set of well-defined logical tasks. And remember, always functions are more or less independent of others. Maybe your function, that whatever you have written, may not be dependent on some other function, or it need not wait for the result of some other function to complete its own set of tasks. Or sometimes it may be dependent on some other function that is waiting for the result in order to perform its own set of tasks. So a function has been written in order to perform a well-defined task. So basically speaking, functions, they divide a large program into number of smaller piece of subprograms so that they can execute their own set of logical tasks. So here let us take a simple example how these functions are going to work. So normally we have a main function. If you see the structure of a C program, we used to include the preprocessed directives, and then we have the global declaration, and we write a main function from where we try to execute whatever task has been assigned for our requirement. So we have the main function, and the main function consists of the body of its own functionality, what it is supposed to be do. So here, let's say for example, there are certain set of statements that are getting executed in the main function, and suddenly there is a function call that is happening. So here, if you see the example here, function 1 is getting called. So immediately the control passes to the definition of the function 1. And once the definition of the function 1 is being written, all the set of statements that are being written inside that function 1, it will get executed. And once the execution process for this particular function is getting over, then the control passes again to the next line that is available in the function call of the main function. So I repeat again. So basically what happens here is you have a main function that has some set of statement blocks, and after a few set of statement blocks, you have the function that has been getting called over here, and immediately the control passes to the function, and this function is getting executed with all its statement block, and then the control passes to the next line of the main function, and then all the statements that follows after the function call is getting executed. So this is how normally your function works in C, not only in C, in any programming language. So the function that is main, it has been termed as the calling function, and the function 1 is called as the called function over here. So always remember, the main function can call as many functions as it wants, and the called function can also call many functions inside it. So for example, if this particular statement blocks, it is going to have a certain set of function calls over here. That is, let's say for example, function 2 and function 3 are called from function 1. So it means that the called function can also call many functions over here. Okay, so moving on, let us see why we are getting into the concept of functions, or what are all the merits, or what are all the advantages of getting into the functions. So functions, normally it enhances, or it simplifies the process of getting the total program to work. So as I told you, instead of writing some large programs, we try to break the programs into subprograms in the name of the functions. So in case of any error where a particular functionality or feature is not working, we can touch that corresponding function and we can get it rectified instead of searching where the error is getting happen. So it divides the entire piece of code, okay, into smaller sections of code. So here, let's say for example, you have a main function that is calling the function 1. So once the main function is calling the function 1, all the statement blocks that has been written in function 1 will be getting executed, and then the function 2 is getting called. So function 2 in turn, it is trying to call function x and function y. So function 2, in order to complete its own set of process, it will execute function X, and then it will execute function Y, and once these functions are executed successfully, then the control again passes to the main function where the function third is getting called. So here basically there are 3 function calls in the main function, and among which the second function call is going to call 2 more functions within itself. Okay, so this kind of approach is actually a top-down approach where the main function is getting called first, and in that main function we have 3 function calls, and in those 3 functions called, the second function is going to call the function X and function Y. So how the sequence of calls will be, you will have the main function will call function 1 is getting executed successfully, then we call the function 2. Function 2, in order to execute it has to call function X as well as function Y. These functions are getting executed successfully in a sequential manner, then the control passes to the main function where the third function is getting executed and called. So this approach is actually a top-down approach in terms of a function call. So moving on further, we are going to see again what are all the different advantages of going for functions. So one thing is, if you separate out the set of code in terms of or in the name of functions, it is very easy for you to understand, it is very easy for you to develop the coding as well as to test the separate functions. So one thing is, it gives the programmer an easy understanding of what they are supposed to do, how to code and how to test the separate functions. And the second thing is, it also increases the speed in developing a particular program, and it allows the programmer to focus on only the code that what he wants to write for the specific function. So let's say, for example, you are supposed to develop a scientific calculator. So there are hundreds and thousands of functions in a scientific calculator. You cannot write all those functionality within the main function. So here what we do is, let's say for example, we have the logarithmic functionality, we have the trigonometric functionality, we have the matrix operation functionality. All these functionalities can be separated out as different functions. So if you have a team of programmers who are working on this particular scientific calculator, what they can do is they can this particular scientific calculator program has been divided across the different set of programmers. They can focus on which particular module they have to focus on. So let's say for example, there is a programmer X. He is going to write the coding for all the trigonometric functions. So his concentration will be only on the trigonometric operations. And let's say for example, there is going to be a programmer Y who is going to focus only on the mathematical matrix operations. So he will focus only on the mathematical matrix operations to develop the functions. So one advantage is that the functions allows the developer to focus only on what code he has to write or what code he is supposed to write. So the workload of the programmers is divided and it is getting reduced. So these are some of the advantages when we choose functions in order to break down the large program into smaller ones. So programmers can write a function once and it can be used many times. So you can write a function once, and whenever it is being required, you can call the function. So moving on, we are going to see how the functions call each other. So let's say for example, I have a main function and it has started executing some statement blocks, and suddenly I have a function call here. Okay, so function 1 is getting called. So immediately the control passes to the definition of function 1. So inside function 1, whatever statement blocks are there, they will be executed successfully, and then the control passes to the called function. So here what happens is function 1 is getting called, so the control passes to the function 1. So the definition of the function 1 is getting executed. So again we have certain set of statement blocks, and here we see function 2 is getting called immediately. So function 2 is getting called, the control passes to the definition of function 2, and function 2 starts getting executed. It starts executing its own body of the function, and here again we have a call that is function 3. So the control again passes from function 2 to function 3, and function 3, it starts executing all the statement blocks that are available inside the function 3. So once all these statement blocks are executed successfully in function 3, the control again passes to the next statement that is available in the function 2. So now the function 2, it will try to execute all the statement blocks that are available in the function 2 after the function 3 is getting called. Now what happens? So once this particular statement blocks are executed successfully, the control passes to the function 1 where the function 2 was called. So what happens here? The function 2 is getting called and it has been executed successfully. So now the rest of the statements that are available in function will be executed successfully, and again the control will pass to the main function. So I repeat again, the main function is getting called here. The main function is started executing. it will first execute the set of statements that are available in the main function, and here we have a function called, that is function 1 is getting called. So the control passes to the definition of function 1. And what happens here, once function 1 is getting called, the statement blocks are executed inside the function 1, and there is another function call here, that is function 2. So function 2 is getting, the control passes to the function 2 from function 1, and all the statements are executed in function 2 before another function is getting called. So function 3 is getting called in function 2, so the control passes to the function 3. So all the logical statements are executed in function 3 successfully, and then the control passes back to the function 2, and the remaining statements are executed in the function 2, and again the control passes to the remaining statements that is available in the function 1. So once the function 1 is getting executed successfully, then we go back to the main function where the remaining statements are getting executed successfully. So this is how the functions call the other functions normally in a C program or in any other programming language. So next we are going to see what are all the terminologies we are trying to use in functions. So the first and foremost thing, let's say for example function f uses a function g, which means I write a function f, and inside the function f, okay, I am trying to use the function named, that is g. So here f is called as a calling function and g is called as a called function. So since f is using the function g, f is called as a calling function and g is called as a called function, or you term the g as a called function. So whatever input a function is going to accept or it is going to take as an input, that is called as an argument or parameter. So technically speaking, the input that function is going to accept is called as an argument or parameter. So the called function, sometimes it is going to return some value or some result to the calling function. So this again we will discuss later with some examples. Next we are going to see about the function declaration. So one terminology, every function should be declared in your program. So the function declaration is something that it's a declaration statement that is going to identify the name of the function, that is a function name, and then the list of arguments that a function is going to accept, and the type of data the function is going to return. Basically it is we call it as a return data type of the function. The next terminology that we are going to use is the function definition, where we have a function header for the function definition that is going to identify the function name as well as the body of the function. So here we are going to see the syntax, how you can declare a function or how you can develop the prototype of a function. So basically we need to have a return data type. Basically every function should have a return data type and then the name of the function, and you have to pass the number of input arguments that are getting used inside a function. So let's say for example, when we try to declare a variable in any programming language, we first try to give the data type of the variable and then followed by the name of the variable. So similarly here, when we try to define a function, we need to identify what is the value that that particular function is going to return in the name of the data type, and then we have to give the name of the function, and we have to mention what are all the list of input arguments that the function is going to accept. So basically, as I told you, the return data type is going to specify the data type of the value that is returned by the function. So every function, it is going to do some kind of process and it is going to return some kind of result, and that result should be identified by the return data type. So next we are going to see about the function name. So the function name is going to specify the valid name of the function, and as I told you, whatever arguments that you are going to give, we are going to represent it in terms of the data type followed by the variable name. So here we are going to list out what are all the variables that are going to be accepted by that particular function and what it is going to process. So let's see some examples. So here let's say for example, I have defined a function char toLower of char c, and I have so since it's a function declaration, you have to end up with a semicolon. So as I told you here, the name of the function is toLower and the data type of the function is character. So which means the function toLower is going to do some kind of process and it is going to return me the result in terms of a character. So let's say for example, I want to pass a character as an input argument to this particular function toLower. So let's say for example, I'm trying to give a uppercase letter, say capital A. So capital A will be passed as an input argument. So that input argument has to be defined. What type of data we are trying to pass to this particular function. So it is of a character data type, and that variable name should also be identified. So here the variable name is C over here, okay, and the data type that I have defined is the character. So this particular line char C indicates about the input argument that has been accepted by the function, that is to lower, and the data type, return data type, will be of the character nature. So next, let's say for example I'm using another function declaration, that is float mean of int x comma int y. So again, the name of the function is mean. The data type that the function is going to return is a float value, that is in terms of some decimal values, and here I am trying to pass two input arguments x and y, both are of the integer data type. And the next example, here I am trying to identify the maximum value among the three numbers. So the return data type of this particular function max is integer, the name of the function is max, and here I am trying to pass three input arguments, that is integer a, integer b, and integer c. So another example of different data type, I am using double as a return type of the function name, that is prot, and this particular function accepts two input arguments. So it is going to process the values of a and b. The value of a is in terms of double data type, the value of b is in terms of double data type. And another function here, sometimes your function can return no value. So in order to indicate that, we can make use of the data type that is void. So here is one example. I have defined a function, I've declared a function that is swap, and the return type of the function is void. It can accept two input arguments x and y. And suppose as I told you, this list of arguments that we are trying to pass, okay, it can be optional. Sometimes your function may not accept input arguments. It depends upon the nature of requirement that you are trying to write the code. So here if you see, for the first example, the function accepted one input argument. In the second example, to find the mean, it accepted two input arguments. And here if you see the third example, it is trying to accept three input arguments to identify what are all the to identify what is the biggest number among three. So sometimes your function may not accept any input argument. As I told you, it depends upon your requirement. So as of now, we'll just try to understand, okay, how to declare the function or how to develop the prototype of a function. So basically you need a return type, the name of the function, and then you have to list out the list of arguments that are used inside that particular function, followed by a semicolon. So this is the syntax in order to write a function declaration. Now what happens if I'm not going to give any variable name inside the argument? So it doesn't matter if you're not going to give any variable name inside the argument, but at least you have to mention what is the data type of the argument that you are trying to pass. So the name of the argument, the name of the variable name inside the argument is optional. Okay, so you can even mention about the data type that is getting passed, that can be listed. So here in this particular function, float mean, the return type of the function is float, the name of the function is mean, and it accepts two input arguments, that is both are of integer nature. So you can see the second example and then the this corresponding example what I'm pointing out to. Okay, so both mean the same. Okay, the thing is that I have missed out the variable name x and y here. Okay, that doesn't matter. So it is fair enough if you have only the data type as the input arguments for the function declaration, more than sufficient. And what happens if I'm not going to give any type of return type for a function? So whenever you're not trying to point out any return type for the function, so by default the compiler will return any integer value. By default the compiler will return any integer value. So but it is always a best practice in order to mention what is the return type for any function that you are trying to write. Okay, so these are some of the examples that I have pointed out, okay, where you can declare the function with the different data types and different list of arguments, but always remember your function should have a very good meaningful name. Okay, so moving on further, next we are going to see how you can, what is there inside a function definition. So basically when a function has been defined, the memory space has been allotted for that particular function. So it is going to implicitly act as a function declaration. So normally speaking, the parts of a function has two. One thing is the function header and the other one is the body of the function. So what does the function header has? The function header, okay, it will basically have the return data type, the name of the function, and then the list of variables that are being accepted as the input argument. So this is going to be your function header. So that is why I marked in red. This is going to be your function header. That is, the function header will first point out what is the data type of the function. So this return data type should match exactly with the function declaration, and the name of the function should also match with the function declaration, and then the data type that is been given inside the function declaration should match in the function header of the function definition. So then starts your body of the function. So the body of the function will have certain set of statements that are supposed to be executed by the function, okay, and then you will have the return value of the particular function. So every function will return some value, and that return value will be in terms of a variable. So when since we have marked as a variable over here, sometimes the function will return a value or a variable, or it may even return some constant values. Okay, so this we will again discuss with some live examples. Okay, but just note down what is the syntax of the function definition. Okay, so whenever I repeat your function is being defined, okay, it means that a memory space will be allotted in the memory for that particular function. So basically your function definition will have two parts. One is the function header and the other one is the body of the function. So the function header here I have pointed out in red. Okay, so it will have a return data type, and then the name of the function. It will also have what is the list of variables that are getting passed inside the function. So which means these variables will be used by the body of the function. That is the meaning over here. Okay, so the body of the function will execute the actual logical task that is being targeted for this particular function, and finally the function will return some value. So this is the syntax, okay, how to write the function definition. So the list of variables inside the function header is called as the formal parameters, and as I told you, sometimes the parameters may be optional. So it can have a function header can have 0 to many parameters. So 0 in the sense your function may not accept any input arguments, or it will not have any input parameters or variables of any data type. So there may be no parameters, or it can have many number of parameters for your function. So moving on further, we are going to discuss about the function call. So function call happens inside a main function or any other function. So which means basically a function call is trying to invoke the function. So what happens is the compiler jumps to the called function, and it is trying to execute all the statements that are written inside the body of the function. So here what happens is the function call, once it happens, the compiler will pass the control to the function definition. That is, the function header will be accessed with its return type, with its name of the function, as well as the input argument that is getting passed, and then it will try to execute the body of the statement, the body of the function that is being written for the corresponding function. So after execution, the control again passes to the calling function. So I already told you about the examples that we saw. So whenever we are trying to call a function, the actual function is getting invoked. So the compiler will pass the control to the called function, and it will try to execute all the statements that are available inside the body of the function. So after the execution, the control passes to the calling function. So what is the syntax of function call? The syntax of the function call, so you have to simply give the name of the function, and then if it has any input arguments, those input arguments should also be passed. So the compiler checks for the correct number of arguments as well as the data type of the arguments, and it will also see whether the correct return value is getting matched for the function call. So for example, if I say I have passed I have two input arguments for my function. So during the function call, I have to pass two input arguments. So that speaks about the correct number of arguments. And let us say, for example, the type of the argument that I am passing. What is the data type of the argument that I am passing? Whether that is also getting matched or not. That should also be checked by the compiler. And finally, once a function is going to process something and it is going to return some value, the return data type of the value should match with the data type of the function. So these are the three things that the compiler will check during the function call. So the list of variables that is used actually in the function call is called as the actual parameter. So there are two types of parameters. One is the formal parameter that is used inside the function definition, and the actual parameter that is used during the function call. So parameters, as I told you, it can be either variables or it can be expressions or it can be constants. So even the return statement, it can be either a variable or it can be an expression or it can be a constant.